Hi everyone, this is the start of Unit 4. So these last two units were on ordinary simple annuities and ordinary general annuities. This unit, as well as it talks about the remaining types of annuities. So this first lesson is going to talk about simple annuities due. Okay, so you remember a simple annuity is where the compounding frequency, okay, so interest compounding frequency and payment frequency are the same. Okay, but an annuity due, what that means is instead of paying at the beginning of the or at the end of the month, in an annuity due you pay at the beginning of the month. Okay, so like I said already, we've talked about ordinary annuities. So now in these next two lessons, we're going to talk about annuities due. The first item this lesson will be a simple annuity due. Okay. So, like I said, compounding frequency and the payment period are the same, but it's at the start of the period, not the end, okay? So if you're paying monthly, you'd pay on the first day of the month as opposed to the last day of the month, all right? So just to have you kind of show it visually, okay? So when we initially did annuities, we had time zero, and then at the end of each period, we'd either obtain $100, let's say it's an annuity that we're getting money, or we pay $100. So something like that could be, like car payment, mortgage payment, something like that. So all we're doing is we're shifting every one of those payments to the start of the period. So that means as soon as you start, right, time zero, instead of waiting until the end of the period to get that $100, you're getting it at the start. All right? So it's pretty simple. There's only one change to the formula. The formulas all look identical to an ordinary simple annuity. The only change is that because it's at the start of the period now, you're actually earning interest on that first period. Okay? So the entire term gets multiplied by this term, 1 plus I. So remember, in a simple annuity, I is the periodic interest rate, okay, per compounding period. That's the only item that changes. So all your values will be a little bit higher because you have one extra period that you're earning interest. And this is consistent for the future value formula, the present value formula, and the payment formula that we're going to talk about today. I'm not going to go over the formula for N. With this additional 1 plus I, once we start manipulating the formula with Lon, it gets a little more complicated. So I'm not going to cover that in this unit. Just before I go to the next slide, one item to notice is for this future value formula, N, okay, was the initial one for a simple annuity. All I did is put in brackets due, okay, so that's just saying that it's an annuity due. So let's look at a few examples. You deposit $100 at the beginning of each month for 5 years in an account, paying 4.2% compounded monthly. How much money will be in the account at the end of the 5-year period? Okay. A couple items to notice here. It says payments are at the beginning of the month. That means it's an annuity due. And your compounding frequency is monthly, and your payment frequency is monthly, so they're the same. So that makes this a simple annuity due. Okay. I'll switch back to red. So we're trying to figure out how much money is in the account at the end of the period, meaning the future value. So we can start with our formula. The future value, again, I put in brackets due here just so we signal that this is for an annuity due. And it's equal to your payment times 1 plus your periodic interest rate to the exponent n minus 1 divided by your periodic interest rate. And that's multiplied by this additional 1 plus I term, okay, because it's an annuity due. So every other step is the same as a simple annuity, okay? So my little sidebar that I have on the right, you know your payment is $100. Your nominal interest rate in the question is 4.2%. which is 4.2 divided by 100, removing the percentage sign, or 0.042. Your compounding frequency, M, is 12 because it's monthly. So your periodic interest rate, I, is equal to J divided by M, or 0.042 divided by 12, which gives you 0.0035. Okay? Last item you need is N, okay, and it's the number of years times the number of periods per year. In this instance, in a simple annuity, the compounding frequency and the payment period frequency are the same. So it was given in the question that it was 5 years, so N is equal to 5 times 12 payments a year because it's monthly, which gives you 60. So if you substitute all these values into the formula, future value for an annuity due is equal to 100 times 1 plus 0.0035 to the exponent 60 minus 1 divided by 0.0035 multiplied by 1 plus 0.0035, that extra interest term. So if you calculate each of these out, again, I'll do this in steps. Your future value is equal to 100, and in this bracket, it is 66.636 if you calculate it out. And your last term would be 1.0035. So if you calculate all of these out, you get your future value is equal to $6,686.92. Okay? So what you'll notice is that the formulas and the method are all the same. Okay? They don't change. The only item that changed was this addition of the 1 plus the periodic interest rate term at the end. And that's just to account for that additional period you're earning interest, since you're depositing or you're being paid, depending on the question, at the beginning of the period instead of the end. So let's look at one more example with future value. Frank deposited $250 at the beginning of each month for 4 years into a savings account. Interest is 4.5% per annum compounded monthly. What is the balance at the end of 4 years? Again, they're asking for the balance at the end of 4 years. That means it's a future value. And a couple items to note. First of all, interest is compounded monthly and your payments are monthly. Okay, so that makes it a simple annuity. And your payments are at the beginning of the month. That makes it an annuity due. So this is a simple annuity due. Okay, as we get more and more and more types of these types of items become important for you to recognize. Okay, so we start again with the formula. The future value for an annuity due is equal to the payment times 1 plus the periodic interest rate to the exponent n minus 1 divided by the periodic interest rate times this additional term, 1 plus the periodic interest rate. So again, start a sidebar on the right. Your payment given in the question is $250. Your nominal interest rate, J, is 4.5%, which is 4.5 divided by 100, removing the percentage sign, or 0.045. Just like the last question, your number of compounding periods is 12 because it's monthly. So your periodic interest rate, I, is J divided by M, or 0.045 divided by 12, which gives you 0.00375. Your last item, N, okay, in this instance, it's 4 years. So 4 multiplied by the number of payments a year, which is 12. So that gives you 48. Substituting all of these values into the formula, future value for an annuity due is equal to 250 times 1 plus 0.00375 to the exponent 48 minus 1 divided by 0.00375. And that's again multiplied by this additional term, 1 plus 0.00375, okay, the periodic interest rate. So if you do this in steps, all right, your future value is equal to 250 times this item in brackets comes out to 52.4838 multiplied by 1.00375. So if you calculate this out, your future value comes out to $13,170.16. Okay? So now if we take a look at the present value formula, again, the formula is exactly the same as an ordinary simple annuity. Okay? So we have our present value, and this formula just denotes that it's an annuity due. And it's still equal to the payment times 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n divided by I, the periodic interest rate. But again, because it's at the beginning of the period, we have this additional 1 plus I term, and that is just adding the additional interest for that first period, okay? Because we're actually earning interest right from the start. Otherwise, the method to calculate this is exactly the same as an ordinary simple annuity with that one additional inclusion. So I've got a couple of examples calculating the present value, and then we're going to look at calculating payments. So first example, you make $3,000 payments at the beginning of each year for 5 years. What is the present value if interest is 6% per annum compounded annually? Okay, so a couple things to notice. Again, we're at the beginning of each year, okay, so that means it's an annuity due, and your payments are yearly, and your interest is also yearly, okay, because they're both annual. That makes it a simple annuity due, because the interest and payment period frequencies are the same. So it asks right in the question for the present value. So that means we can start with our present value formula. Again, we know it's an annuity due, so we use this slightly revised formula. So the present value is equal to the payment times 1 minus 1 divided by 1 plus your periodic interest rate to the exponent n divided by your periodic interest rate I multiplied by the additional 1 plus I term. Okay? So just like we did on the future value questions, what items do we know? So we know our payment is provided. It's $3,000. Our nominal interest rate, J, is 6%, which is 6 divided by 100, removing the percentage sign, or 0.06. Our number of compounding periods is annual, so M is 1. So that means our periodic interest rate, I, is J divided by M, which is 0.06 divided by 1, or just 0.06. Lastly, N, okay, in this instance, it's 5 years, multiplied by 1 payment a year because it's annual, so N is 5. Substituting all of these values into the formula, our present value for this annuity due is equal to 3,000 times 1 minus 1 divided by 1 plus 0.06 to the exponent 5, divided by our periodic interest rate, 0.06. And that's multiplied by 1 plus 0.06. Okay? Again, just like the last questions, if we take it in steps, your present value is equal to 3,000 times the brackets, which is equal to 4.212 times 1.06. And if you calculate this out, you get $13,395.32. Okay? So again, just like future value with that one additional term. Let's look at one more example using present value. What is the present value of a 3-year lease of office facilities renting for $536.50, payable at the beginning of each month if interest is 9% per annum compounded monthly. Okay, so a couple things to notice. Interest and payment period frequency are both monthly, so they're the same. Makes it a simple annuity. And payments are at the beginning of the month, so that makes it a simple annuity due. All right, and it asks in the question for present value. So we start with our formula. Present value for an annuity due is equal to your payment times 1 minus 1 divided by 1 plus your periodic interest rate I to the exponent n, divided by your periodic interest rate I, and that's multiplied by this additional 1 plus I term. So again, everything we know, our payments, okay, are $536.50. Our nominal interest rate J is 9%, which is 9 divided by 100, removing the percentage sign, or 0.09. Our number of compounding periods per year, M, is 12 because it's given as monthly. So our periodic interest rate, I, is J divided by M, or 0.09 divided by 12, which is 0.0075. Our last term, N, okay, we're given that it's a 3-year lease, so it's 3, times, since payments are monthly, 12 payments per year, so we have a total of 36 payments. So multiplying, or placing everything into the equation, our present value for an annuity due is equal to $536.50 multiplied by 1 minus 1 divided by 1 plus your periodic interest rate, which is 0.0075, to the exponent 36, divided by 0.0075, multiplied by this additional interest term, 1 plus 0.0075. Okay? So if you calculate these out again in steps, the present value is equal to $536.50 times 31.4468, that's this term in the brackets, times 1.0075. And calculating all of this out, you get a final answer of $16,997.75. Okay? So our last item we're going to talk about, again, I'm not going to talk about finding the number of payment periods n, just because the math gets a little bit trickier with this additional term. But finding payment, again, is exactly the same. Okay? It depends if you know the future value or the present value. But again, this 1 plus I, or additional interest term, is added to the equations to make up for that additional interest that's being earned. Okay? So in both cases, it's in the denominator. And that's because when you rearrange this formula, okay, you end up having to divide, and that's why this additional term sits in the denominator. Okay, but all you need to know is that if it's an annuity due, you just have to include this 1 plus I term. Okay, so I'm going to look at one example using future value and one for present value. Okay, the methods are still the same. It's just that you have a different formula depending on if you're asking for future value or present value. Okay, and again, these formulas will be provided for you as a formula sheet for your test. So let's look at our first example here. Okay, what semi-annual payment must be made to a savings account at the beginning of every 6 months to accumulate to $9,600 in 10 years at 7% per annum interest compounded semi-annually? Okay, again, you'll notice a couple things. Interest is semi-annual, your payments are semi-annual. That makes it a simple annuity. And payments are at the beginning of the month, so that makes it a simple annuity due. Second item you're asking for is it's asking for the payment, all right? And it's asking for it accumulating to $9,600. That means if it's accumulating to a value, that's the future value. All right. So we know we're trying to find the payment and we know the future value. So starting with our formula, okay, our payment is equal to our future value. Again, I put due in brackets to note that it's an annuity due, times your periodic interest rate I, divided by 1 plus your periodic interest rate to the exponent n minus 1. Okay, that's all in brackets, multiplied by 1 plus the periodic interest rate. Again, that additional term because it's an annuity due. So let's look at the items that we know. Okay, we know the future value for this annuity due. It's accumulating to $9,600. Our nominal interest rate is 7%, which is 7 divided by 100, removing the percentage sign, or 0.07. M, okay, our number of compounding periods, it's semi-annual. So that means M is equal to 2. So our periodic interest rate I, which is J divided by M, is equal to 0.07 divided by 2, or 0.035. Our last term, N, okay, this is 10 years long, so it's 10 multiplied by the number of payments periods per year, which is 2. So we get 20. All right, substituting these values into our formula, our payment is equal to 9,600 times our periodic interest rate, 0.035, divided by 1 plus 0.035 to the exponent 20 minus 1. Again, that's all in brackets, multiplied by this additional 1 plus 0.035. Okay, so doing this in steps, and again, making sure that you do everything correctly, our payment is equal to 336 in the numerator, divided by this first term, okay, the 1 plus periodic interest rate to the exponent 20 minus 1. If you calculate that out, you get 0.9898. And your second term is just 1.035. So calculating that out, your payment comes to $327.99. All right, it's important to make sure when you're doing these questions, if you're trying to follow along with the video, take a look at what I get for these intermediate numbers. Okay, and if you're not getting the same numbers in each of these, in this instance, 3 locations, then whatever location you're not getting the same numbers, start there and see if you made a mistake, whether it's not following order of operations or maybe something else. All right. All right, our last example. Okay, so again, trying to find the payment, but in this case, knowing the present value. So what monthly rent payment at the beginning of each month for 4 years is required if the present value of your lease is $7,000 and the interest is 7.5% per annum compounded monthly? Okay, again, I sound like a broken record, but I like to do this every time. All right, it's the beginning of each month, makes an annuity due, and your interest is also compounded monthly. Okay, so compounding and payment periods are the same. So that makes this a simple annuity due. Okay. Second item to notice is you're provided the present value and you're asking for your rent payment. Okay, so it's trying to find payment and you know the present value. So you start with your payment formula knowing present value. So your payment is equal to your present value for an annuity due times your periodic interest rate divided by this term, which is 1 minus 1 divided by 1 plus your periodic interest rate to the exponent n, all in brackets times this additional interest term, 1 plus I. Okay? Again, the items that you know, okay, you know your present value for this annuity due is given in the question, $7,000. Your nominal interest rate, J, is 7.5%, which is 7.5 divided by 100, removing the percentage sign, or 0.075. Your payments are monthly, all right? So your number of annual interest compounding frequency is also monthly. So your value of M is 12. So that gives you a periodic interest rate, I, is J divided by M, which is 0.075 divided by 12, which is 0.00625. The last item that you need, N, okay, so it's given that these payments are for 4 years, and you have 12 payments a year because it's monthly, so that gives you a value of N of 48. Substituting all of these values in, all right, your payment is equal to your present value, 7,000, times 0.00625, your periodic interest rate, divided by this large term, 1 minus 1 divided by 1 plus your periodic interest rate, 0.00625, to the exponent 48, times this additional interest term, 1 plus 0.00625. Again, taking this into steps, if you multiply this out, your payment is $43.75 in the numerator, divided by 0.2585. Okay, that's this first term here, multiplied by the second term, 1.00625. Okay? And if you multiply that out, you get $168.20. Okay? So that was it for this lesson. It was a shorter lesson than ones in the past. So I encourage you just to kind of start spotting these differences in the formula. Okay, so we've done 3 different types of annuities. Ordinary simple annuity was in Unit 2. Ordinary general annuity was Unit 3. And this first lesson was on simple annuities due. Okay, so your next lesson will be on general annuities due. Okay, so you'll kind of see the differences there. So at that point you'll have 4 different types of annuities. So spotting these differences that I do at the start of each question becomes important. Just like in the past, if you do have any questions, please feel free to send me an email. Thanks.